So in the last videos, we covered a lot of Terraform topics, right? So in this video, what we will do is we will implement all those Terraform topics in creating Kubernetes version 1.28 cluster. So basically Kubernetes current version is 1.28. So we'll try to create Kubernetes cluster using Kubeadm on AWS, but using Terraform and Ansible. Okay, so we will cover a lot of Terraform topics. So these are all the prerequisites that we require. Okay, we should have a system with AWS CLI installed and IAM user credentials configured. Okay, so you can take any machine. Okay, so you can also use T2 micro instance with AMI as Amazon Linux too. And you should also have Ansible and Ansible playbook binaries installed, Terraform and Git installed. Okay. So in my
Yeah,
case, Ansible playbook command will not work as expected in Windows. That's the reason what I will do is I'll write all the Terraform configurations required to provision cluster on Windows. And then what I will do is I will, uh, you know, commit all those files into Git repository, and then I'll clone that repository into one of the EC2 instances. There, I will make sure that I have AWS CLI, Ansible, Terraform, and all those binaries installed and configured. Okay. So we
yeah,
will develop the configurations in Windows. Of course, I can run on Windows, but the only thing is Ansible playbook binary is not working as expected. Okay. So this is what we are going to do. Okay. We are going to provision, um, a Kubernetes cluster that to version 1.28 using Terraform. Okay. So we will
yeah,
try to create multiple nodes. Okay. So we have master node and, we will use a couple of worker nodes. Okay. And we will have a machine with all the CLS installed. And once we have all the configurations ready, we'll simply do Terraform apply. So automatically nodes and Kubernetes related components will be installed and the cluster will be bootstrap. And one more thing we need to remember is this is only for dev and learning. Okay, because I may not follow all the best practices to provision the cluster. Okay. So in production, either you can go for managed Kubernetes services like EKS. Okay. That offers much better security. So this is just for the dev and learning purpose only to understand how to use Terraform Ansible to create a Kubernetes cluster on AWS. So for creating Kubernetes cluster, already I have documents under this YouTube series repository. So if you go to Kubernetes and then cluster setup, so here you'll have uh, MD file, a markdown file called Kubernetes on AWS with container D. I think this is an old version that will install, I think, Kubernetes probably one dot, I don't know, like two or I'm not quite sure. Okay, so this is an older document. Okay, so the latest Kubernetes cluster provisioning with 1.28 is here. Okay, so this is using Kubeadm and containerd as container runtime. Okay, so if you see, we have some prerequisites like we need to have Linux host with 2 GB RAM and 2 vCPUs. Okay, for master we'll take one, and for the slaves we can take two nodes. Okay, slaves can be T2 micro, but master should be T2 medium. Okay, and then you should have unique host name for all these three machines. And so master has certain requirements. Okay, so every component needs some port to be open. So for on master you should have these ports open, and for the slaves you should have these ports open. Okay, and you should have um, swap disabled on all the nodes, and then you need to install containerd, install runc, container networking interface, CRICTL. Okay, and then certain configurations. Okay, then later we'll install kubectl, kubeadm, and kubelet. Okay, on all the nodes. So this these commands are required for all the nodes. And on the master node, what you should do is you can directly run kubeadm init, okay, to start creating the cluster. Okay, but Kubeadm init will take some time pulling the images. So if you want to pull the images first only, you can pull all the images using Kubeadm config images pull, and then you can run Kubeadm. Okay. So after you run Kubeadm, you need to also install the cluster networking. Okay, that is CNI plugin. So we are using VNet, and that too the latest version. So all the tools that we have mentioned in this document uses the latest versions only, okay, which are relevant for version 1.28 cluster. Okay. And then as you already know, once you do Kubeadm in it, you'll also get a join token, right? On the
Yeah.
master node. So this join token command has to be pasted on all the slave nodes, and the slave nodes will connect back to the master. Okay. So this is entire cluster provisioning, and also there are proper links in order to understand how to set up the cluster using Kubeadm. So there is also this official documentation that you can follow. Okay. Now what we will do is we will start with all these configurations in the form of shell scripts. Okay. So I have two shell script, one to provision the master and one to not provisioning, one to run in the master node, and the other one is to run in the worker node. Okay. So in the master node, if you see, I'm trying to set the host name, and the host name, whatever host name I require. When I call this master.sh, I need to pass the argument. Okay. Like I should call it using master.sh space some name, then that will be used to rename this host. So hostname CTL is the utility, right, to name
Yeah.
the host. And then if you see, I have commands to disable swap, and then installing containerd, installing RENC, installing CNI, CRICTL, and then installing kubectl, kubelet, kubeadm. Got it? And
Yeah.
then once Kubeadm is installed, I'm actually printing Kubeadm version, and then running Kubeadm config images pull, and then running the Kubeadm. Okay. And once you run Kubeadm, okay, so let me show you. In this Kubeadm documentation, there is this Kubeadm minute. And once you do Kubeadm minute, at the end, it will show you all the other steps. Okay. Like how to copy the kubeconfig file, and how to install the container networking interface. Okay, so everything will be shown on the CLI itself.
Okay.
Got it. The same commands I have
Yeah.
taken. Okay, so basically, you will find these commands. So I'm running all those commands, whatever Kubeadm displays on the terminal. And then finally, I'm
Okay.
installing the, this VNet CNI. Okay, got it.
Yeah.
And see, once you do Kubeadm minute, you'll also have the join command, right? So the join
Yes.
command, I need to run it on the slave nodes. So what I'm doing as a special step is, I'm going to, anyways, it is going to print. Okay. So if you want to create one more join token, then what you can do is you can run this command inside the master node, kubeadm token create and print join token. So this will create one more command. Okay, it will display one
Okay.
more command, and then that command I am just saving it into join hyphen command.sh, a file on the master node. Now what I will do is I'll take this file from the master node into my local machine, and then I'll copy it back into the worker nodes, and then I'll execute that command. Then worker nodes will
Okay.
join. Got it?
Yeah.
Okay, so basically what the join token command file will be here. That file, I'll bring it back to my local machine. And when I'm trying to configure slaves, I'll also copy that file and run that file using remote exec provisioner. Got it? Then all
Yeah.
the nodes, slave nodes will, worker nodes will join the cluster. And also there is this worker.sh. Okay. So worker.sh, if you see, almost all the commands are same. It is just a replica actually. Okay, it is
Yeah.
completely okay, copied from the master node. There are no special requirements. Okay, so
Okay.
now we will start with creating, various resources, right? So first thing what I'll do is, I'll initialize this as, Git repository, because I want to push it into Git, and then I will clone it into a VM from where I will execute all these commands, because locally I'm not able to execute Ansible commands. Okay. And also I have this readme.md file. Okay. So that shows what all tools you need to have and how to install it on Amazon EC2 instances.
Yeah.
And then there are certain references. Okay. So we already configured one EC2 instance with Ansible Terraform in one of our previous session. Okay, so we can also refer to that. Okay, so first thing what I'll do is I'll make it as Git repository so that I can push all these contents into Git and I can clone it into machine where I can run Ansible commands. So git init. Okay, so this is the first command. Okay. Or else, since it will show you all these changes first, it is not required. So let me delete it for now. So let's create it later. Okay, so we have everything, or master.sh and worker.sh. So we'll start with creating a first instance. Okay, so we'll try to create master instance. Okay, so let's say this is ec2.tf, or let's simply call it as main.tf. And then we have to create an EC2 resource, right? So let's say this is master node. So launch master node, and then we have resource called AWS underscore instance, right? So this is instance name, and the local name I'll call it as k8 underscore master. Okay.
Yeah.
And then inside this, what all we have to get? So we need to have AMI. Okay. So we need to have AMI, and also we need to have the instance type. Okay. Sorry, this is a different one. Okay. Instance type. Why it is giving this? Okay, instance type. This is one. And then let's say we will also go for some tags. Okay. So tags also we can use. So tag. So tag, if you use a name, okay, so this will be name used to name the master node, right?
Yeah.
In the AWS console. So you will exactly see a VM with name called k8 under k8 hyphen master. So this instance type and all, I don't want to actually provide it here. Okay, so let me create a separate file called variables.tf. Okay, so here, what variable we will use? We'll use a variable called AMI. Okay, and the type you can make it as a string. Okay, and the default value. Okay, so what should be the default value? We should use the
Yes, he's from.
you know,
Yeah.
so here AMIs, I can use one AMI for master, one a different AMI for slave or the worker. Okay, so for this you can either use one single AMI ID, or else let's say you wanted to use different. Then what we will do? So we'll simply say map. Okay, so map
Okay.
of. So here map means it will start like this. So for the master, I will use a different. For the worker, I'll use a different one. Okay, so for the master, which one we will use? So if you go to the EC2 launch panel and then go to AMI catalog. Okay, so we need to use Ubuntu. Okay, so Ubuntu 20.04. Okay, this one 64-bit. So let me copy it. Okay, so here I'm using the same AMI for both master and the slave. Okay, so if you want to mention only one value, simply make it as a string and proceed. Got it?
Okay. Yeah.
And other than that, which one we have to use? So
Type
variable
instance.
instance type, right? Instance type. Okay, instance type. Type it is string. So let me go directly give the default value, which is yeah, again,
P2
see,
medium,
so
right?
this instance type also for master we have one, and for slave we have to have another one, right? So again, I'm
Yeah.
going to use map of string. So for the master, I will use I think T2 medium, right?
Yeah.
Because it is there in the document as
Prerequisite.
T2 medium, and then T2 micro. Okay, for the slave. Okay, and yeah, so here I'll go to main.tf. AMI, what I'll do, I'll get it from var.ami. Okay, so var.ami. Okay, so var.ami. Okay, so it is not var.ami because it is not a single value, right? Okay, so
Yeah.
let me move it to the right. I'll split it to right, so it is easier. Okay, now if you see, So this is not a string, this is map of string. So in order to access this master, it should be AMI dot master. It can be like this, or else we can use this notation. Got it?
Yeah.
Understood?
Yeah, okay.
Okay, so you can use either of these. So let me go for this. Then instance type is again var dot instance type. Again, I need to use master. Okay, so tags, I'm directly giving it here. If you want tags, actually you can also give it in the variable section. Okay, but the thing is, we did not mention the provider, right? So let me create one more file for the AWS provider. Okay, so provider.tf. Then what we will do is we will go to Terraform registry. Exactly. So Terraform registry, and then let's search for browse providers. Go to AWS provider. Just click on this use provider. You will have this document complete. Okay. Right. We already know this. So in the provider.tf file. So actually everything is there in the same folder. Okay. But the view is different. It is the same thing. Okay. So we are using the latest provider, and provider we need to configure, right? So how do you configure? So if you want to know the provider configurations, just go to the documentation, and in the main screen only, they'll show you what all configurations. So first thing is I need to mention the reason inside this block. Okay. So again, reason, I can make it as a variable, right? So let me go to the variables, and then, so let me give it on the top. Okay. So it is easier for us to. Okay, so variable, so I can say it as a reason. Type is string, I am not mentioning. So let me go to the default value. So which one? US East one. Okay, so let me confirm which AMI we have taken. Okay, so if you go to AMI catalog, Northern Virginia, US East one, right? Okay, yeah. US East. And yeah. So now I'll save this file, go to the provider. So provider again, I'll directly give from var.reason. Okay. And here we also need which one? Profile, right? So that profile means which local profile from the AWS CLI. Okay. So if you don't want to use CLI, you can directly put your access key and secret access key here, or else you can, if you have a file. Okay. So basically that file will be inside your home location under .aws folder, a file called credentials will be there, right? Okay, yeah. I can mention that, but the best thing is simply use a profile. Okay, so in the AWS CLI, we'll have a profile, right? That is always default. I mean, there will be multiple, but initially we are going to use the default only. Correct? Yeah. So let me go to default. So don't worry about the indentation. We will fix all these indentations using Terraform FNT later. Otherwise, what we will do is we'll try to do it now only. So let's open the terminal. Okay, so I already have Terraform installed in my local machine. So Terraform commands will work. Otherwise, before starting all these things, you need to make sure that all the CLIs like Terraform, AWS, CLI, and Ansible, everything is there. Okay, so let me do Terraform. Init is not required because I'm not going to execute here. But if I try to do Terraform FNT, let's see if it, yeah, it is not asking for the provider. Okay. Yeah. So FMT means
if you do plan, it will ask, I guess.
Yeah. So here, I think for validate also it should ask. Okay, for FMT it is not asking. That is good. Okay. So now we have provider also configured. Nothing else is required from this one here. So let me close it. Okay. So in the variables also we have declared some variables, and then we have used it here. Okay. So this, so we'll concentrate on the first EC2 instance, that is master creation. Okay. And also we will be copying a lot of files. That means we'll be using connection blocks, right? So which means I need to have the private key with me. Okay. So what I will do is I'll also create a public and private key, and I will push my public key into AWS as a key pair. Okay. So for this, what we have to do, we have to use key pair resource, right? So key pair dot tf. Okay. So what we can do, we can go to Terraform documentation and then search for, I think it is key underscore pair only. Okay. So it is AWS underscore key pair. Okay. So this will create a key pair. What I can do is I can create a public and private key, and then I can upload only the public key into AWS. Okay. So let's copy this complete thing. Okay. Here. And then public key, let's completely remove it. Okay. From this location. I mean, so we are not going to, use this key, right? So let me generate a new one. It's a very big key. Okay, so I deleted it. And here, this is AWS key pair resource. The name of the resource, let's say K8s. Okay. And then key name also, let me use it as K8s key. So the same key I will use for all master and slave instances. And then public key. So what I'll do with public key is, okay, so first within the same folder, let me generate a key pair. So SSH keys and as the file name, let me use it as K8s key. Okay. Or else simply K8s. Okay. So let's press enter continuously without entering any passphrase. So here I have a private key and then I have a public key. Okay. So this public key, I'm going to upload it. Okay. So without revealing the contents, let me use the file function. And as an input, let me give the location of the public key, that is kh.pub. Since it is in the same location, I'm not going to give the full path. Got it?
Yeah.
Right. Now let me open the main.tf. So here I can use, I can give the key name, right? So which key this AWS is going to use. So how do I refer to this AWS key? Through resource referencing. Okay, it is AWS underscore key underscore pay dot K8s dot key name, right? Okay. So let me do that. So AWS underscore key pair dot K8s dot, it will automatically give you all the suggestions. So it is basically key name. Okay. Then save it. And yeah, so this key is also done. Then so if you look at the prerequisites, what all we need to have? So we need to have the security groups. Okay. So let's look at these security groups and then try to create. Okay, so let's go to the security group resource. Okay, I think it is security underscore group. I'm also not sure. Yeah, it is under VPC AWS security group. Okay, so this will create a security group. Okay, so there is a security group resource name description. So VPC will ignore it for now. And then there are some ingress and egress rules and some tags. Okay, so let take this whole syntax. Okay, then what we'll do, we'll create another file here. So we call that file as uh, security groups dot tf. Okay, so let me paste the ones that we already copied. Okay, so the name of the security group, what we will use is security groups will be different for master and slave. Okay, so let me call it as k8s underscore master. This is the local name. Okay, so globally I'll call it as, I mean within the AWS I will call it as k8s underscore master. Okay, so I should use SG. Just it is an indication that it is, this name is a security group. And description, so let me say same K8's master, let's say security group. Okay, so VPC, let me delete it. Okay, now let's look at the ingress, what all things we require. So we require 6443. Okay, 6443.2 TCP. So first, so this is, let me rename it. So this is for the API server. Basically, description I'll use as API server, and the port is 6443 TCP. Okay, the CIDR block and all, if you see, so this is relevant to VPC. Okay, But
Yeah.
I want to open for everyone. So let me copy these. Okay. Cider blocks. And then let's paste it here. Okay. So this is for the API server. Okay. And egress, if you see, I'm opening everything for now. And that is the only, that is one of the ingress. I also need to open SSH, right? Because I wanted to SSH for configuring these via Ansible and lot of stuff. We will see it later. Okay, so let's also open SSH and the port number is 22. That is done. Okay, now the other thing is we need to open from 23792 to 2380 for etc server client API. Okay, so let me copy one of the ingress and then paste it. Okay, so I can configure it. Okay, so this is for the HCD, right? It is CD. So it's said from 2379 to 2380. Okay,
Yeah.
got it. Now let me copy paste the same thing for other and here we have 6783 TCP and 6784.
UDP.
Okay, UDP both 6783 and 6784. Okay, so one. So let me call it as VNet. Let's say it is TCP, and then let's call it as which one? It is 6783. Okay, again this should be 6783. It is TCP. Got it. The same we need to copy for UDP also. Okay, so the port will be UDP. I think it is what?
84.
6784. Okay, 6784. Okay, that is ingress. And let me go to the other one. So we have 10 248 to 260 for kubelet, kube control manager and all. So let me copy this so that I can use it for description. Okay, so let me write it for some time here. Okay, I'll take an ingress block, copy it here. Okay, and then so it is asking us to use this 10248. Okay, so 10T48, 10260, and this will be TCP traffic. Okay, so this is for all this. So let me cut it here. Okay, and then paste it as a description. Got it?
Yeah.
Okay, and similarly, so for the node port services, okay, so this generic ports I won't open it for now because 80 80 80 443 I don't require for the, but for the node port services I will open this port. Okay, copy it just for time being, copy any of the ingress rule. Okay, so 30,002 and 32767. This is for the node port range. Okay, that's it. So let me delete the extra text type, copy it. Okay, so as a tag, okay, I'll use the same name. Okay, KH underscore master underscore SZ for this security group tag. Got it?
Yeah.
So this is for the master. So what about the slaves? So slaves, okay, so slaves also requires the same. Okay, I think for HCD, whatever port that we have used, that is not required. Okay, so we need 22 and then 6783, 6784, 10248. In fact, node port range also is required. So you can use the same security group for, for the slave also. Okay, opening an extra port doesn't make any, doesn't give you any problems. Okay, but so let me copy the same resource, whatever we have. Okay, and then paste it. So let's start editing. So this we call it as K8's
Slave.
worker. Okay, and then let's start replacing it everywhere. Underscore SG worker security group. SSH we require. API server
We don't require.
67367. it's not 6443 is not required. Okay, so let me delete it. Even HCD is not required. Let's delete. So VNet is required, kubelet is required, and the rest of the things. Okay, and then we will call it as worker SG. Got it?
Yeah.
Okay, so now we have a security group. So we need to go to the main, and then what we will do? So we will add security group. So the name will be security underscore group. So this will be actually an array. Okay, so how do you refer to a security group? Okay, so it is AWS underscore security groups dot k8 master. Okay, so a slave will go for slave. Okay, or else security groups will be created already, right? When we actually create, right? So before creating this
Yeah.
instance, security group will be created. What will be the name of the security group once it is created? This name, right? K8's master underscore SG. So directly also within this array, you can mention it like this. Okay, so this is also possible. Okay, so we have key name, security group, and instance related things mentioned. So now what we will do? So once this resource is created, okay, so we need to configure it using master.sh file, right? Okay, so there are two ways. One, you can use user data, and then you can use file function to give your master.sh file. Okay, but the disadvantage is we will not have visibility over what exactly is happening in that user data script. Okay, because it won't be printed on the terminal. Okay, so that's the reason what we will do. We will go for remote exec provisioner. Okay, for remote exec provisioner, so first we need to copy the file, and then we need to run remote exec provisioner. Okay, and for that, first we need to have connection block, right? So we'll go for Terraform provisioners. Okay, so provisioners Terraform. Okay, so we'll go for provisioner connections, and then so let me take the connection block, okay, of okay, from here, and then let's paste it here. Okay, so connection type is SSH, user is, so that's a Ubuntu VM, the user should be Ubuntu. Okay, the host should be, we already know, right? It is self dot public IP. Got it?
Yeah.
And then we don't have the password, we have the private key. So once you start typing, it will show you. So private key will be, so I'll provide a file from my local machine, which is K8s, right? So there is no extension for this K8.key. There is no extension. It is simply K8s. Okay. Got it. So that is the connection block. Now, once connection is established, what we need to do? So we need to copy this master.sh file, right, into the VM. So for that, I'll use the file provisioner. Okay, so the source and destination, let me copy this type of configuration. So provisioner is file, and then within my local machine, I have this master.sh. Okay.
Yeah.
And then destination will be, I can put it anywhere, but let me put it in slash home Ubuntu. Okay. The slash Ubuntu. So the file name called master.sh. Okay. So our file will be copied. Now, when the file is copied, what I have to do? I have to execute it, right? So for execute, I need to use remote exec provision. So let me go to remote exec, and where are the other examples? Yeah. So remote exec and inline. Okay. So first I need to change the permissions of that script, right? I want to make it executable. So I've made it executable, change mode plus X, given the full path of the shell script that is copied into the VM. And then what I need to do, I need to execute it with sudo privileges. So sudo sh, and then the location of the shell script. Okay. And here, if you remember, inside the master.sh, it is also expecting some command line argument. So that will be used to rename this instance. Okay. So what I will pass is, I'll pass a name called k8-master. Okay. So my VM's host name will be changed as k8-master. Got it?
Yeah.
Understood?
Yeah, Vikram.
Okay. Clear till this point?
Yeah, Vikram. Yeah.
Okay. And yeah, so I think so we executed. Yeah, so we have executed, and then what we have to do? That's it. Okay. Similarly, what we need to do, we need to also configure the slave, right? Got it.
Yes.
So slave also, let me copy the whole VM, whole configuration, and then paste it in the same file. So now I'll change it to launch worker notes. Okay. So the resource name I'll use as k8 hyphen worker. Okay. And AMI is var.ami. So we have a separate AMI for worker. Instant type also we have for the worker. Okay. And then tags. Okay. So here tags are okay. So what if I want to have multiple slave nodes? Okay. So for this, let me go to the variables. Yeah. So let me declare another variable called. So which name we'll use? We'll use worker instance. Let me say count. Okay. So the type will be here number. Okay. And the default value, let's make it to 2. Okay. Now let's go to main.tf. So if I wanted to provision multiple EC2 instances, what I have to do? I have to use count, right? Okay. So how will use? So count. So count will come from
variable.
Okay. So count will come from var dot worker instance count. And here, so we also know the concept of interpolation, right? Where I can actually have dynamic string. So instead of tagging all the worker nodes with a static name called k8-worker. Okay. So I wanted to include the index number as well. Okay. So hyphen dollar within the flower braces, I'll use count.index so that so whatever the index value, so when the count is 2, so indexes will start from 0 and it will go up to 1. So first worker node will be k8-worker-0. Next one will be 1, right? Okay. And here the same connection block, instead of master.sh, so we will upload worker.sh, and then we will change the permission once it is copied and worker.sh. So here also, so when I'm trying to pass the first command and argument, that will actually change the what do you say, host name. What I should use? Interpolation syntax. Okay. So here also k8-worker hyphen, so same syntax, right? The dollar within flower braces, it is count dot index. Got it?
Yeah.
Okay. Count dot index. So why there is this comma here? This comma is not required here. And also this is not required because that is a list, right? So last element should not have that comma. Okay. So here we are able to actually provision the instances, and also we will configure.
Security group also will be changed.
Yeah, correct. So security group also, it should become what? Thanks. Okay.
Yeah.
So far everything is good. And if you look at master.sh, okay, so it is actually creating a file. Okay, that file will have a command to join the worker nodes. Okay. So I've checked a lot of Terraform concepts, but I was not able to actually take a file back from node, I mean the EC2 instance, back to my local machine. I was able to copy through file provision, but there is no, I mean, I'm really not sure whether I can take a file back from instances using Terraform. So that's the reason what I did is I actually used Ansible playbook to take this file out of this VM. Got it?
Okay, got it.
So what I will do now is we will create a playbook. Okay. So that playbook will have the copy command. Okay. Not copy. Copy is from local to manage node. So we'll use the fetch. Okay. So we will call this file as let's say maybe playbook.yml. Okay. So let's go to fetch module. Fetch module and Ansible. Okay, let me just take the example. Okay, so let's click on the example and then source and destination. Okay, but this is no, this is simply a task. Okay, so we need to write an actual playbook. Okay, so if you look at the sample playbooks, basically it starts from host, right?
I felt, yeah.
So host, let me target all the hosts, but currently I don't have the host file. We will see. Okay, and the name of the playbook is let's say fetch join token file. Okay, and gather facts. I think it will consume a lot of time. So gather facts. Let's make it to false
False.
because I don't require any conditionals here. Whether it is Ubuntu based VM or CentOS VM, whether it has APK APT yum package. I don't require all those details. So that's why I'm actually turning off the facts and coming to the tasks. Okay, so this is the only task. Okay, so what is my task? Okay, so fetch, let me say fetch join token file or join command file. So the src, so where exactly we are storing inside that Ubuntu's home location only. Okay, so it will be slash home slash Ubuntu slash. Okay, so join command dot sh. Got it?
Yeah.
And the destination, I would like to copy into the same folder here by the same name, join command dot sh. Okay, got it?
Yeah, got it.
And also, see here. So once it copies right here, okay, so we will find some issues with the this what do you say? This fetch module. So whatever file that you fetch, like if you are fetching from slash home slash Ubuntu, so that folder structure will be created. Okay, I don't want to create a folder structure and then copy that file. Okay, I want the file to be copied exactly here. That's why we'll use flat set to yes. Got it?
Okay.
Otherwise, home folder will be created inside it. Ubuntu will be created, and again inside that the join command.sh file will be created. I don't want all those things. Okay, so here we have basically used this playbook, but it also needs the configuration, right? Okay, so configuration means how your the master node, and I mean your local machine has to connect to this managed nodes, right? So for
Yeah.
this, we also should have ansible.cfg. So ansible.cfg can be in multiple locations. It can be in etc ansible, it can be on home location, it can be set using an environment variable. Okay, but if you don't have ansible configurations any other place, the ansible configuration in the same directory where you execute ansible playbook commands will be considered. Okay, and then if you anyways, let's not waste time. So we already know how to write the defaults inside the ansible.cfg. So under the defaults, so I want my Ansible commands to use Ubuntu as the remote user to connect. That's the first thing. Okay, because I'm not using any username and the private key that I have to use to connect to the node. Okay,
Yeah.
got it? Because my local machine has to connect to the master node to fetch a file, right? Which means my local machine has to know how to connect to the master node. So remote user is Ubuntu because I've used Ubuntu AMI. And also, I think how do I give the private key file? Let me search. Ansible CFG. Ansible CFG. I think it is private key file probably. Let's see. So private key file. So what is the private key file? So within my location, I have this K8s, right? You can see here.
Yeah.
Okay. And also the other option is host key checking should always be set as false. Okay. Otherwise, your Ansible, it is not always, it is not recommended for the production environments. Since this is a test environment, we are setting it off. Got it?
Okay.
So our
Yeah.
Ansible configuration is done. Now what we will do is we need to run this Ansible playbook, right? So when the when the this mask node is created and all the provisions are executed. So now what I have to do, I have to execute the Ansible playbook in my local machine, right? So for that I need to use local exec provisioner, right? So this local exec provisioner. Okay, so let me but before executing I also need one more thing. Okay, so local exec provisioner. So the local exec provisioner, what command it has to run? It has to run Ansible -playbook command. Okay. So it needs an inventory, but where is the inventory? So I don't want any inventory, right? Because there is only which one? One IP address. Okay. So -I.
Correct.
So what is that IP address? That single IP address, as I already said, it should be put inside quotes, and then you should also have a comma. Okay. So that the first IP address, okay, the master IP address, you can get it by self-referencing the public IP of this, and also you need to put comma, otherwise it won't work. Got it? And then what is the name of the playbook? It is simply playbook.yml because it is already there in the local machine. Okay. Got it?
Yeah.
So now my local machine will talk to this using this IP address. Hello?
Yeah, welcome. Got it.
Okay. So this is okay. So using playbook. Now that file will be available here, right? Okay. So that file I wanted to copy, but before doing this, so we need to set the dependency order. The reason why dependency order is required is, so until all the commands in this master node is are completed, we should not start the worker instances. So that's the reason why we need to use depends on. Okay, somewhere you need to put depends on, and then you need to mention AWS_instance.k8's master. This one. Okay. Then once all the steps are completed in the master node, then only you will basically start the worker instances. Okay. So now our playbook just copied that join command.sh in our local machine. So from our local machine, we need to copy into the remote node, right?
Yeah.
I mean the worker node. So how we will copy? Again, we will use a file provisioner. Okay. So I can use the file provisioner. I'll just copy the syntax. So all the file provisioners, I can put it here.
Okay.
Now, 1 second, whether it is possible. Yeah, anyways, worker.sh will be copied here. And before k8's worker is initiated, that join command file will also be available, right, in my local machine, which means it will work without any fail. Okay. Now, what will be the file name which the file will be copied? If you look at the playbook, so this is the file name that will be available, right? So from my local machine, okay, so this join command.sh file has to copy it into home Ubuntu again.
Yeah.
Got it? Just remove the extra paths and dots. Okay. So now the join command is also there. So worker will be configured, and then join command also has to be executed, right? So I can put it here. So once that worker.sh is executed, so let me add one more command. So that we'll do sudo sh, and then let's execute this file, right?
Yeah.
So the join command file will also run. Got it?
Okay. Got it.
Okay. So I think almost everything is done. Anything is left. Okay. So we will also define the output blocks. Okay. So we did not define the outputs, right? Because I wanted to see the outputs of my my master instance, my slave instance. So output, let's say master. Okay. So what will be the value? So it is AWS underscore instance dot k8's master. Since there is only one. Okay. So let me get the public IP of this. Got it?
Yeah.
And then we will also talk about the workers, because there are multiple workers. So we will get a list. So value will be AWS underscore instance. Okay. So K8 is worker. We have multiple, right? So within the brackets star dot public IP. So if I have 10, so all the 10 will be printed.
Okay.
Got it?
Yeah.
Anything else we missed? I think we did not miss anything, right? Okay. So let's quickly do Terraform FNT to fix all the formatting issues. Then let's do Git init. Okay, so because I cannot run these playbooks here due to Ansible issue, I'm going to run it in another instance. So git add all. Okay, so let me create a remote repository quickly. Okay, so let's create a new repository called. So what is the folder name? So let's use the same folder name. Okay. Create with this name. Make it publicly available. That's it. Create repository. Okay. So let me add this origin into my local. Okay. So git add is done. So git commit -m init. Okay. And then git push origin master. Got it?
Yeah.
Okay. Now let's go to the repository. And there is also this. Okay. So this public and private key. Anyways, we are going to destroy, right? That is fine. Okay. Yeah. So everything is uploaded. Now what we will do is, so we'll clone this content into a machine with all the dependencies. So let's go to EC2 and then let's launch an instance. Okay. You can use any VM. Okay. So if you look at the README file, so I've used yum as a package manager, which means I'm using Linux CMI. So I'll call this VM as
Terraform
Terraform.
local.
Yeah. And then let's choose the Linux CMI 2022 instance IP is T2 micro. So key pair, I'm using the one which I already have so that I can SSH from my local machine. Okay. Or else you create a new one if it is required, and then allow SSH. Yes, it is required. Then launch the instance. Okay. Go back to the instances. Okay, so Terraform, this is the one which should. Okay, so there is this public IP. I'll use MobaXterm. Okay. To SSH, or else you can use any tool. So right click, new session, SSH. This is the public IP. Username is EC2-user. I already have the private key called Ansible that I've used when launching an instance. Okay, so let's click on OK. So I'll be able to SSH into this Terraform instance. I think instance is being provisioned. It is provision, so which means I should be able to SSH. Okay, so become sudo. Okay, so first thing is in this VM, you already have AWS CLI installed, so you don't have to do anything. And then I need to configure the IAM user, right? So let's click on IAM. Let's create a separate IAM user for this demo. Okay.
Okay.
and go to the users. So create a user called dev something. Don't provide AWS management console access. Click on next. Attach policies directly. Give him the administrator access. Click on next. Next. Create user. Okay. So now once the user is created, click on the user. Go to security credentials. Access keys. Create a access key. And this access key we are going to use for command line operations. So select CLI. Click on next. Okay. Just check this, understand, and click on create access key. Now you have the access key and secret access key. So we need to configure the AWS CLI in our machine. Okay. So by using AWS configure, right?
Yeah.
Okay. So AWS configure, let's copy the access key first. This is the access key. Okay. Anyways, at the end of this demo, I'm going to delete this and secret access key. So let's copy the secret access key as well. Okay. So default reason, let's not set any default reason. We'll set it from Terraform configuration. So I'll just press enter and then press enter. So our AWS CLI is configured. Now we need to make sure that we have Git install to clone that repository. So yum install simply git -y. Okay, and after that we need to have Ansible install. So in this VM, the Linux Amazon Linux 2 already Python 3 is installed, so we can install Ansible using pip3 and install Ansible, which we already did it for our earlier demo on integrating Ansible and Terraform, right?
Yeah.
Okay, so once you install Ansible through pip, basically Ansible will be under user local bin. That user local bin won't be in your path. Okay, so you need to
Path.
add it to a path. So you need to add this export command into bash rc and then load bash rc. Okay, you can do it manually or else you can do it through those two commands. Okay. Okay, so Ansible is installed. Now let's copy those two commands to update the path. Okay, and then if you do Ansible -v, it should respond. Okay, it is responding. Now let's install Terraform. Okay, so I can use a separate repository. So I can add that repository and install Terraform. Okay, just copy all these three commands and install Terraform. Okay, so we have Terraform installed, AWS CLI with IAM user credentials configured, and then we have Git also installed. Okay, so let's go to the Git repository that we created. Okay, and then let's clone it. So take the clone command, I mean the HTTPS URL, and then do git clone. Okay, and the URL. Got it?
Yeah.
So cd into that repository. Okay, so we don't have to do anything right now. Okay, so we have all the files. Okay. So first thing we need to do is Terraform init to download all the providers. Okay. And then, so we did not miss anything, right? So we have to one master node and two worker nodes. Okay. So Terraform plan you can do, and then to Terraform apply, but I'm directly using Terraform apply -, auto approve. Okay. Okay, so it is creating K8 key pair security groups for master and worker. And then it is trying to initiate K8 master AWS instance creation. Okay, it is still creating. So meanwhile, we can also check all the running instances, running instances. Okay, so Terraform, this is the our node. Okay, so CKAD master is I think it is created now. Provisioning with file. So first that master.sh file will be uploaded, right? So it is connected, and then you can see it is installing containerd and all those things, right?
Yeah.
So let me open another session, duplicate it so that we can see that join token command is cd into that ls-5. So we should see that join command.sh file, right? Once.
Yeah.
Okay. So currently it is installing containerd and running it as a service. Okay, it is now installing RENC, that is runtime for the containers. And now it is what it is doing. Okay, installing CRICTL. Now it is trying to probably install kubelet, Kubeadm, and kubectl. Which one it is doing? Now it is downloading Kubeadm and then kubelet, kubectl. Okay. Then it should pull the Kubeadm images, Kubeadm config images pull. You can see pulling Kubeadm images, so there is small typo here. Okay, so it should pull Kube API server, controller, scheduler, etcd, pause container, all this stuff, right?
Yeah.
And then it should do Kubeadm minute. So once it is done, it will anyways show the join token, but I cannot copy that token. So that's why I created a new token and then created a file in the master. And then using Ansible playbook, I'm just taking it out. Okay, you can see the joint token is already. But what I did is I actually, oh, what says? Which says failed. Okay. Unable to calculate the checksum of the remote file. So since our playbook is failing, so what we'll do is we'll try to run it with sudo privileges. Okay, so we will edit the playbook, and then here, what we'll do is we will try to become or run this by becoming the root user, and that means with sudo privileges. Okay, so let's save this playbook, and then we can actually try running this playbook. Okay, so using the playbook command, let's see if it so it says fail to connect to the host. It says unprotected private key file. Okay, so what we can do is whatever the private key file that we have by the name K8s, so we will try to change the permission to 400. Okay, then let's try to run the playbook. Now you can see I think the playbook is successful. If you try to do ls-l, I think that command, the file got copied. Okay, so let's remove that file from my local machine, and then let's try to recreate the whole infrastructure. Okay, so for this, first what we have to do, we have to destroy it, right? Because it is not provision completely. So let's try to destroy whatever resources that got created. Okay. So now
Yeah.
we will try to apply it again. Okay. So file provisioner is getting executed. So it is running master.sh file. Okay, so it is bootstrapping the cluster and then it is trying to fetch the config file. You can see it fetched. Okay.
Yeah.
And then now if you see, it is trying to create worker nodes parallelly. Okay. So both will run slave.sh and then this join command file will be executed. Okay, so the node is trying to, okay. So I think the nodes join the cluster and then this is the master node and these are all the slave nodes IP address. Okay. So let's try to SSH into the master node, SSH -I. Okay, so K8s is the key, right, that we have used.
Yeah.
Okay, and then Ubuntu is the user at the rate of this is the master IP address. Okay, so now let's become sudo, and then let's use kubectl get nodes. Okay, you can see we have 3 nodes and all are in master in the ready state. You can also see the version they are running. Okay.
Yeah.
So this kubectl get pods -a to get all the namespaces pod. You can see here all the parts are up and running. Got it? So let's
Yeah.
exit from the master node, and then we can use kubectl terraform destroy or taproot to destroy this whole cluster. Got it?
Yeah.
Okay, and before destroying, so let's actually upload the contents of this. Okay, so let me update the playbook.yaml in the repository. Okay, so let's edit this, and then let's overwrite this. Got it?
Yeah.
Then let's commit the changes into the master branch directly. And then let's destroy this whole infrastructure using Terraform destroy -auto approve. Okay, so this is how we use Terraform and Ansible to provision AWS, Kubernetes cluster using Kubeadm on AWS.